People ask what happens to consciousness when you die. They want a comforting answer. They want to know if the quote unquote self goes somewhere or if it just turns off like a broken television set. But as a physicist, when I look at the equations of quantum mechanics, I have to stop and ask a much more aggressive question. What makes you think you are a single, continuous, permanent thing in the first place? Now, look, let's be very precise here. We have this profound, stubborn, evolutionary intuition that consciousness is a noun. We treat it as a localized flame burning inside the skull, a passenger sitting behind the eyes driving the vehicle of the body. But in physics, we don't deal in flames or souls or mystical passengers. We deal in information. We deal in quantum states. And if you are going to ask a physicist about death, you have to be prepared to abandon your biological biases and look at the raw, unforgiving mathematics of reality. Before we can even begin to talk about where consciousness goes, I want to tell you about the law that is more fundamental than gravity, more fundamental than Einstein's relativity. It is the conservation of information. We call it unitarity. It is the absolute bedrock of quantum mechanics, and it dictates that quantum information can never, under any circumstances, be created from nothing, and it can never, ever be destroyed. You can take a physical book, let's say a massive encyclopedia, filled with highly ordered, structured information. You can throw it into a roaring furnace. You can burn it to ash. You can crush the ashes into a fine gray dust, and you can scatter that dust into the ocean. To your classical, macroscopic human eyes, the information in that book is gone. It is destroyed. But the universe does not agree with you. If you had a powerful enough computer, a theoretical quantum supercomputer that we call a Laplace demon, you could track the exact deterministic trajectory of every single carbon atom, every wisp of smoke, every photon of light emitted in that fire, and you could run the laws of physics in reverse. You could perfectly reconstruct the text of the book. The universe never loses the ledger, it just scrambles it. So, when the highly complex biological machine that is generating your consciousness finally breaks down, the quantum information that made up your specific localized configuration doesn't vanish into the void. The universe doesn't have a delete button, it only has a scramble button. The point is actually quite subtle, and it's where physics hits a hard wall. Physics doesn't know what it feels like to be scrambled. Science cannot tell you what it feels like from the first person perspective when the highly ordered, low entropy system of your brain suddenly loses its lifelong battle with the heat bath of the environment and disperses into the background radiation of the cosmos. But philosophy, specifically rigorous philosophy grounded deeply in modern theoretical physics, gives us three very distinct, mathematically motivated answers to what happens when the observer ceases to observe. The first answer is what we can call the physicalist scattering, and it is entirely dictated by the brutal, unforgiving laws of thermodynamics. Let me sketch a closed system right here on the board. Imagine this box is your body, your brain, your entire physical existence. For decades, from the moment you are born, you are fighting a massive, exhausting, uphill battle against the second law of thermodynamics, which states that the total entropy of an isolated system can never decrease over time. Mathematically, we express this as delta S greater than or equal to zero. You, as a living organism, are a localized pocket of insanely low entropy. To maintain this highly ordered, incredibly improbable state, you are constantly eating, breathing, and pumping usable energy into this system, turning low entropy fuel into high entropy waste just to keep the cellular machinery running. Your thoughts, your memories, the subjective feeling of the color red, the memory of a childhood home, these are not floating in a spiritual ether. They are precise physical configurations of billions of synapses, cascading electrons, and complex neurochemical gradients. From this strict physicalist perspective, consciousness is not a passenger inside the vehicle. Consciousness is the hum of the engine itself. It is a process, a dynamic action. It requires a constant flow of energy to stave off thermal equilibrium. In physics, thermal equilibrium is just another word for death. So what happens at the moment of physical death? The process simply stops. The engine seizes. The delicate boundary between you and the rest of the universe collapses. But remember unitarity. The fundamental particles do not vanish. The electrical charge does not disappear from reality. The complex information encoded in your neuronal structures simply loses its coherence. It undergoes a process called decoherence, where the delicate quantum states and structured classical pathways of your brain become hopelessly, irrevocably entangled with the surrounding environment. The heat of your body radiates outward. The molecules that made up your neurons break down and disperse. You don't cease to exist, you just cease to be localized. You become part of the background noise of the hospital room, the earth, the atmosphere, and eventually, the expanding universe itself. From a strictly materialist viewpoint, death is just the ultimate phase transition. The illusion of a singular, isolated self is finally dropped, and you return to the massive, chaotic, high-entropy bath from which your atoms were temporarily borrowed. It's a bit of a nuisance for our ego, which desperately wants to remain a cohesive unit, but the thermodynamic ledger must balance. You don't die in the sense of absolute erasure, you just diffuse. You become a permanent, microscopic vibration in the thermal history of the cosmos. But it gets much stranger, because there is a second answer, and this is where we have to leave classical thermodynamics behind entirely and walk directly into the bizarre, counterintuitive, and frankly terrifying world of quantum mechanics. Now, some brilliant minds, like my colleague Roger Penrose, whose work on black hole singularity theorems is absolutely legendary, have argued for a long time that classical physics, no matter how complex, is simply not sufficient to explain the hard problem of consciousness. Penrose, working closely with biologists, has suggested that consciousness isn't just about the classical firing of neurons across synapses, but about delicate quantum coherence happening deep inside the brain's cellular structures, specifically in protein polymers called microtubules. The idea is that the brain is essentially acting as a warm, wet quantum computer, and consciousness is the subjective experience of the quantum wave function collapsing. They call this mathematically precise process orchestrated objective reduction. Now, I won't pretend I agree with every detail of Penrose's biological models. The brain is a hot, noisy environment, and maintaining quantum coherence in there is a nightmare of a physics problem. But let's be good theoretical physicists for a moment and follow that quantum logic to its absolute, inescapable, and somewhat horrifying extreme. If we live in a universe fundamentally governed by quantum mechanics, we cannot ignore the measurement problem, and we certainly cannot ignore Hugh Everett's many worlds interpretation. When a quantum system is in a superposition of states, meaning it exists in multiple possible configurations simultaneously, the traditional Copenhagen interpretation says that observing the system causes the wave function to collapse into a single, definite reality. But Everett realized that the math doesn't actually say that. The Schrödinger equation just describes a continuously evolving wave function. There is no mathematical mechanism for a collapse. Everett said there is no collapse. Instead, every time a quantum event occurs with multiple possible outcomes, the universe doesn't just pick one, it branches, It realizes all of them. The observer simply becomes entangled with the outcome, splitting into multiple versions of themselves, each experiencing a completely different result in a completely non-communicating parallel branch of reality. Now combine this with the sheer incomprehensible scale of the cosmos. If the universe is infinitely large, or if cosmic inflation implies a vast multiverse where every possible configuration of matter exists somewhere, then the exact arrangement of atoms that constitutes you standing there, or me standing here at this chalkboard, is not unique. In an infinite expanse, any configuration with a non-zero probability must inevitably repeat. It's mathematically unavoidable. There are infinite copies of you, right now, in distant Hubble volumes or parallel branches of the wave function, sitting in a room just like this one, having this exact same thought. So, what happens when you die in this particular branch of reality? This brings us to a concept called quantum immortality. And it is, frankly, one of the most deeply unsettling ideas in all of modern physics. If your consciousness is intimately tied to the physical continuation of your brain state, then from your subjective point of view, you can only ever experience the branches of the multiverse where you survive. Let's use a morbid thought experiment: quantum Russian roulette. Imagine you have a gun hooked up to a quantum particle measuring device. If the particle spins up, the gun fires. If the particle spins down, it clicks on an empty chamber. You pull the trigger. According to the many worlds interpretation, the universe instantly branches. In one branch, the gun goes off, your brain is destroyed, and to the outside observers in that universe, you are dead. But here is the trick: you cannot experience that universe because in that branch, there is no you left to process the experience of death. The machinery of consciousness has been destroyed. But in the other branch, the gun clicks. You are still there. You are still conscious. Subjectively, from your own first person perspective, you will always find yourself in the universe where the gun clicked, against all mathematical odds, simply because you are fundamentally, logically incapable of observing the universes where you don't exist. Under this framework, consciousness never actually terminates from the first-person perspective. It just keeps narrowing its path down the increasingly improbable branches of the wave function, where the biological machine manages to keep running. Maybe in one branch you die of a heart attack, but in another, a bizarre quantum fluctuation spontaneously clears your arteries. Maybe you age to the point of biological failure, but in some microscopic fraction of the multiverse, medical technology advances just in time to save you, or the atoms in your brain spontaneously reassemble. Death, in this quantum mechanical view, is an event that only ever happens to other people. From your own frame of reference, the lights never go out. The universe simply refuses to let the observer die. You are trapped in an eternal subjective continuity, isolated in the infinitesimally small slice of the multiverse where your specific consciousness persists. It is an immortality of pure, terrifying probability. But let me wipe the chalkboard clean again, because I want to give you the third answer. And to my mind, as someone who has spent his life wrestling with string theory, quantum gravity, and the fundamental nature of space-time, this is the most mathematically beautiful, the most profound, and the most absolutely weird conclusion of them all. We have to talk about the holographic principle. To understand what happens to information when a highly complex system is destroyed, theoretical physicists have spent the last 40 years staring at the most destructive, absolute objects in the universe: black holes. If you throw that encyclopedia I mentioned earlier into a black hole, the information seems to be gone forever, hidden behind the absolute boundary of the event horizon. Not even light can escape. So causality itself is severed. For a long time, my friend Stephen Hawking believed that this information was truly lost, that black holes just destroyed it. But then Stephen himself proved that black holes evaporate. Because of quantum fluctuations near the event horizon, black holes leak radiation. We call it Hawking radiation. Over billions and billions of years, they radiate their mass away until they disappear completely. Now we have a massive universe-breaking paradox. If the black hole disappears and the encyclopedia is gone, and the Hawking radiation that comes out is purely thermal and random, then we have violated unitarity. The universe has deleted the ledger. I spent years fighting with Stephen over this, literally wrote a book called The Black Hole War about it, because if information can be destroyed, all of quantum mechanics falls apart. If you can destroy the quantum information of a book, you can destroy the quantum information of the entire universe. Science itself would break down. To solve this paradox, me, Gerard het Hoofd, and later Juan Maldacena had to drastically rethink the nature of space itself. We realized something absolutely incredible. The information doesn't fall into the singularity and vanish. As an object falls toward a black hole, from the perspective of an outside observer, it appears to slow down and flatten out at the event horizon. The information gets smeared out and stored on the two-dimensional surface of the event horizon. The entire three-dimensional reality inside the black hole, everything that has ever fallen into it, is perfectly encoded mathematically as a two-dimensional hologram on the boundary. We proved that the maximum amount of information you can cram into a region of space doesn't depend on its 3D volume. It depends entirely on its 2D surface area. The fundamental pixels of reality are not three-dimensional chunks of space. They are two-dimensional bits of quantum information on a boundary. This is the holographic bound. Now zoom out, take this deeply strange mathematical truth, and apply it to the entire universe. Thanks to Maldacena's work on the ADS/CFT correspondence, we now have a rigorous mathematical framework showing how a theory of gravity in a three-dimensional space can be exactly equivalent to a quantum field theory living on a two-dimensional boundary without gravity. What if our entire three-dimensional reality, me standing here, the chalk in my hand, the gravitational pull of the Earth, the incredibly complex firing of billions of neurons in your brain right now, is just a holographic projection of information encoded on the cosmological boundary of our universe? If this is true, and the mathematics of string theory heavily suggests that it is, then what exactly is consciousness? Consciousness isn't a physical thing inside your head. It is a highly specific, evolving mathematical pattern encoded on the boundary of space-time itself. Your brain, your body, your entire life experience is just a 3D hologram projected inward from the edge of reality. So what happens when you die under the holographic principle? When the biological mechanism fails, the 3D projection in this local space changes. The physical body decays, the neurons stop firing, the illusion of a localized observer breaks down. But the fundamental quantum information, the exact mathematical blueprint of your consciousness, every memory you ever held, every subjective experience, every complex thought, the way you felt when you looked at the stars, remains permanently etched into the boundary of the universe. It is a permanent, indelible modification of the cosmic code. You don't go to some mythical heaven, and you don't plunge into a void of blackness. You are literally assimilated into the fundamental geometry of reality. Your existence permanently alters the entanglement structure of the universe's boundary. Think about what this actually means for a moment. We spend our entire lives terrified of the moment the lights go out. We build massive cultural frameworks, grand religions, and elaborate philosophies just to cope with the sheer crushing terror of our own impermanence. We write poetry, we sing songs, we desperately try to understand what happens to the passenger when the car inevitably breaks down. But the physics strongly suggests that the entire premise of our fear is deeply flawed. We are completely misunderstanding our relationship with the universe. You are not a stranger wandering through a cold, dead, mechanical cosmos. You are not a separate entity that was dropped into this universe to suffer, observe for a few fleeting decades, and then disappear into nothingness. You are the cosmos. You are a localized, highly complex knot in the quantum fields, a temporary waking state of the universe trying to understand itself. The carbon in your brain was forged in the hearts of dying stars, and the information that dictates your mind is entangled with the very boundary of space-time. When the biological mechanism finally fails, the localized perspective dissolves. The specific point of view anchored to your physical eyes and ears ceases to exist. But the information, the deep foundational reality of what you were and what you experienced, that is mathematically untouchable. It is baked into the holographic boundary. It is scattered across the thermodynamic heat bath of the cosmos. It is branching infinitely across the Everettian wave function. The universe does not forget you. It mathematically cannot forget you. The strict, unyielding laws of quantum mechanics forbid it. The ledger is always, always balanced. It is up to us to decide if we find that scale of existence terrifying, or if we find it deeply, profoundly comforting, at least until our own local cosmological horizon finally closes in, the last stars burn out, and the universe moves on to its next infinite phase of information processing.